Hello, my name is Abigail Forte, student ID 341384355, and I selected the auditorium or lecture hall to work on for this project. And to develop my algorithm, I used vanilla JavaScript. I was more focused on getting the logic right. So, in order to keep things as simple as possible, I used vanilla JavaScript to code the logic of the algorithm. But before that, like before the implementation using JavaScript, I developed the logic with pen and paper, well, with my brain. And here is my logic. So, based on the way the seats were structured uh, in the classroom, in order to avoid like idle scattered seats, I implemented the algorithm in such a way that it began allocating seats from the middle row. That way, if a latecomer was to come, they won't be struggling to enter into this this column. Rather, because most of the seats in this column would have already been assigned. So that is the main idea behind my logic. And when, like, if there were a group of more than 15 people, which is this row only allows 15 people. If it exceeded 15 people, or the available seats exceeded 15 people, then the algorithm would have to split the row and then assign the rest of the people and split the group and assign the rest of the people to the closest row next to them. That way it keeps the group together, even if some people part of the group were also like maybe had disabled, like needed a disabled seat, or were broken seats. The main idea would be to split the group and then allocate the rest of the group members to as close as the first row as possible. So, given the constraints, as every time you refresh, a new session starts. As you can see, there are different. The broken seats are scattered, and the VIP seats are either E, F, or G and H, like depending on whichever the algorithm chooses to place them. And the disabled seats are two adjacent, either on KL or row J. And so, to begin, like from the point of view of a student, if a student was supposed to come to get seats, like if I was coming with my friends, I'd enter a group of 10 people, then I'll be required to put what seats I desire. If there's it's just standard seats, VIP, or maybe someone would need an accessible seat. And depending on the number of people that I had selected, I would enter how many seats are needed per seat type, and then it would get seats and assign seats. So we had 5 standard seats for from the group, 3 VIP, and of course the 3 disabled seats. So this is just when one person one person books. But I decided to generate data to simulate it in case like multiple students are maybe booking at the same time. And for the first one, I simulated data of 93 93, like if 93 attendees, like to see what happens when the hall is meant to be half full, like how well does the algorithm allocate seats. So uh, 93 are supposed to be booking, and as we can see, it first of all starts by filling up the rows in front, unless in special cases where maybe there's a broken seat like here, or there is like a need for a disability seat like here. But for the VIPs, since like the VIP seats can neither be broken, they're just assigned as they are. And in the case where the group exceeds the number of available seats left in a row, it just splits and comes to the next. So technically, this is how it would look like if 93 people were trying to book at the same time. Not all the 93 attendees attempted to book, but not all of them came through. And if we see here, This is a summary of the data where out of 93 attendees, just 88 managed to go through, and there were 20 bookings, but just 18 were successful, and the other ones were not. They failed due to maybe not having enough space, or not having enough space to be able to accept the number of people that were coming in the group. So moving on to demonstrate how it will look like if at least 75%, like if it was almost full. So I just assume that almost full is at least 75%. That's roughly 140 people. So this is how it would look like if 140 people attempted to book. And as you can see, they're skipping the broken seats and trying to assign it to, like, assign the next possible seat. And according to this here, out of 140 attendees that tried booking, 137 were successful, 6 bookings failed, and 20 were allocated, again either because there was not enough space to accommodate the group, or it just didn't work out. And last but not least, this is how it looked like if 186 people were trying to book all the available 186 spaces in the auditorium. So this is how it would look like. It tried as much as possible to avoid like single idle seats. Like most of the time, if the seats are are if the seats are idle, they'd be on the outer area of the class. That way, if a latecomer is coming, they would be able to just fit in and not have to disrupt people to get out. Like if you were coming from this, you'd be able to fit in. That was the main thing I was trying to do. So that if there are, like, even if some bookings don't work and latecomers do show up, they can just easily enter into the outer seats without necessarily disrupting the people sitting on the outer to get in. And in this circumstance, and in this case, all the VIP seats were booked because in all the tests, I made sure that there were 3 standard rules that each session had to follow. Like there were a certain number of groups that had to show up irrespective of. So that was how I was able to get like a standard to test. And then this is the statistics for the full booking. Out of 186 attendees, just 180 were able to go through. Yeah, and this is pretty much it. So this is the summary of how, and like I said, every time you refresh, it's a different setting, it's a different like 5 random seats. The VIP rows are different as well. I saw the disability seats. So each time you run a test, you get like a unique perspective. Like it's not always the same thing. I just want to see how the algorithm performs under several circumstances. And for the conclusion and this assessment I learned quite a lot. I had to write and rewrite the test, and then to think of the best way to implement the algorithm. At a certain time it was working, and then at a certain time it stopped working. And then I had to like breathe and then restructure and find out the best way possible to do it. And for the module overall, I did enjoy it. Dr. Kane gave us a lot of insightful tips that will not only help us, like not only in the classroom, but like out of the classroom. Like if we're looking to get jobs or break into industries, stuff like that, he usually gave us a lot of tips. And the classes were quite interactive and quite friendly. Like it wasn't just listen, but he'd also make sure he interacted with us, the students, as well. So thank you.